So let's first look at the parent function of the absolute value. So if I say f of x is a function of x, on your calculator we would write it abs x like this, but on your paper you would just write a straight line x, straight line x. Now you guys were taught that whenever you take the absolute value, it's just always positive. Whatever number I plug in those brackets is positive. If I plug in -7, what's the positive of that? 7. So the absolute value of -7 is 7. What's the absolute value of +7? Still positive, so it's 7, right? So now, that's what that does, and it really measures the distance as opposed to the direction. So remember that on a number line, if you go to the right, it's a positive number. If you go to the left, it's a negative number. So for example, if I start at 0 and I go 1, 2, 3, 4, 5, 6, 7 spaces to the left, that value is -7. But the absolute value of -7 is based on the distance that we travel, which is just 1, 2, 3, 4, 5, 6, 7 units. And that's all I care about. So the absolute value is really a way to measure distance. Alright? But let's look at this parent function of y equals the absolute value of x. If you go into your calculator and you hit y equals, you'll get this screen. Your calculator has the absolute value programmed into it. Alright? So let's do that. The easiest way to get there, it's the first thing in catalog. So if I hit second, then I hit catalog, you'll get ABS, open parentheses. I'm going to hit select that, put X, and then close parentheses. Then I'm going to go to zoom, and I'm going to do standard, because Mr. Adams was doing a bunch of graphing last class. And that's what it looks like. Now, basically what's going on here, if I hit trace, when X is equal to -5, my Y value is the positive value of that, right? Another way to look at that is like this. If I go to table, whatever my x value is, I just get the corresponding positive value. So when I plug in -10 to the absolute value brackets, I'm just going to get +10. When I plug in -4, I get +4. Does that make sense? Question?
On my calculator, it gives me the lines, actually.
Yes. On some of the newer calculators, you can actually get the lines. Mr. Adams, let me show you how to do that. If I go to mode, there's two ways to do this. Mr. Adams puts it in classic mode because some of the older calculators don't have the fancy graphics that the newer calculators have. So for example, see how this looks? Now if I go to mode and I switch that to math print, that just means you're fancy. So if you're feeling fancy and you have a newer calculator, yes?
Let me see the fancy.
I can't do that.
You guys ready for the fanciness?
Yeah.
Ready?
Well, bam with the bacon sizzle. There it is.
Wait. I don't get it.
Yes.
Looks the same, sir.
Well, the reason is that these calculators have been around since like the late 70s, early 80s and stuff.
My dad.
And so to put those straight lines in there graphically was not thought of to represent the absolute value function. And the absolute value function is actually a program that's programmed on the calculator. So when they made that program, they just named it ABS. And now it'll automatically pull it up this way. You can still access it the same. Other question? So now what that does is that gives you a graph that looks like this. There's a thing that we call the vertex, and that's where the value starts. It goes from a negative slope to a positive slope. And so the vertex on the parent function occurs at the origin, which is right here. Okay? And so if we transform that function, we'll get some sort of variation of that function. So let's jump into example number 1. So now for example number 1, we want to find y is equal to the absolute value of x minus 4. Now I'm going to do this old school, how Mr. Adams learned how to do it. And what we're going to do is we're just going to plug in some x and y values. Well, we're going to plug in some x values and calculate the y values. Okay? And then we'll see what the graph looks like. Alright? I don't know, I'll just do like -3, -1, 0, 1, and +3. Okay? Now, what happens is I'm going to say f of -3 is equal to the absolute value of -3 minus 4. What's the absolute value of -3?
3.
+3. And what's 3 minus 4?
1. -1.
-1. So when x equals -3, y equals -1. Does that make sense?
Yep.
Okay. So now when I say f of -1, I get the absolute value of -1 minus 4. What's the absolute value of -1?
1.
1. What's 1 minus 4?
-3.
-3. So this becomes -3. When I plug in 0, I get -4. When I plug in +1, I get -3. When I plug in 3, I get, well, actually, -1 again. Does that make sense?
4. Stupid.
Now, if I plot these, and I go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. At -3, I have a -1, which is here. Well, it's more like up here. Then at -1, I have a -3, which is down here. And then when x equals 0, I have a -4. And it kind of looks like this, right? So I'm going to have a graph that kind of looks like... What does that -4 do to my graph?
Takes it down.
Yeah, it just shifts it down 4 from the parent function. So what I'm trying to remind you guys of, and we talked about this yesterday, the parent function, right, which was f of x, well, let's make it something different so you guys don't get confused. Let's call it g of x is equal to the absolute value of x, right? And so by putting this -4, what I'm going to do is I'm going to shift this vertex down 1, 2, 3, 4 units down. So that shifts it down 4 units. What if I were to put a +6? What would that do to the parent function? Shift it up. So now let's watch this in real time, okay? So I have this graph. Now I'm going to take and graph it this way. So I'm going to hit second catalog, just in case you guys didn't get it the first time. And I'm going to plug in x, and then I'm going to go outside of the x, I'm going to say -4. Now I'm going to graph that. So the red line is the transformed graph. Exactly 4 units less than the blue graph. Now if we look at the table of values, we could see here that whatever my corresponding y value is, if you subtract 4 from it, I get the other value. So 11 minus 4 is 7. 10 minus 4 is 6. I suppose we could say, like, if I plug in -7, the absolute value of that would be 7. And then for my second function, if I subtract 4 from 7, I get 3. Does that make sense?
Yep.
Yeah.
All right. So that's pretty much it for example number 1.